Hi, this is Amit Kirti here. In this video, I would like to talk about merge sort algorithm. So the items for discussion are merge sort introduction, merge sort example. We'll look at the merge sort algorithm itself. Then we will try to analyze the merge sort algorithm with the same example. Then we'll try to find the time complexity of merge sort algorithm. Now merge sort is a divide and conquer technique of sorting elements. So merge sort is actually one of the most efficient algorithms. Now merge sort, if I were to summarize in just one or two lines, if we can say that merge sort works as below. Merge sort actually divides your whole set of numbers into sublists, and then it actually sorts these sublists recursively, and then it obtains the final sorted list. So we'll see more when we see about with an example and the algorithm. Since merge sort is a very efficient algorithm, the time complexity of merge sort actually is of the order of theta of n log n. Merge sort was invented by John von Neumann. Now let's say we have these set of numbers, and then let's see how merge sort algorithm works on these set of numbers. Merge sort, as I was saying, divides the set of numbers into subsets and then tries to sort these subsets. So basically when I have these 8 numbers, the algorithm, what it does is it first divides these numbers into 2 halves and then picks up the left half and then tries to sort this left half. So when it picks up this left half, it again divides this into 2 parts and again picks up the left half, and then it actually tries to sort this left half. So when it actually picks up this, it again considers it as a sublist and then takes the left half of this, which happens to be 8, and then it tries to sort. Now since there is only one element and there is nothing to sort, it will actually just go back with this one element. So since we are done with the left half of the sorting, we will go to the right half, which is just this number 3, and then we will try to sort this number. Now since again this is just one number, we will again go back with the same number. So what do we see? We have got 3 levels down and we have tried to sort one element each, and we have these 2 elements. So now you see that these 2 elements are not sorted. So we will try to sort these 2 elements. So now what do? We will actually sort these 2 elements as below. So we have sorted these 2 elements as 3 and 8. So we have first half which is sorted. So we will go back with these 2 elements as being sorted to the upper list. So what do we see here is that out of these 4 elements, we went into recursively, we went inside the left half, we sorted this left half, and then we came back with the sorted list as 3 and 8. So when we come back to this particular list, we have half the elements sorted on the left half, but these right half we never visited. So what we do is we go ahead with this right half. So when we come into the right half, this again becomes a sublist of 2 elements. So what do? Out of these 2 elements, we again go to the left half and try to sort the left half. Now the left half just has one element, so we will come back with just that one element. Then we go to the right half of this and try to sort the right half, and since the right half contains only one element, we will actually go back with just this one element. So we have tried to go into the recursively into the left and right of these 2 elements, and we have come back. Now we have to sort these 2 elements. Since they are already sorted, we will just write back these elements as it is. So now what do we see? That there is one half which is sorted, which is 3 and 8. We also have another half which is sorted, which is 2 and 9. But when we look at all the 4 elements together, they are not really sorted. Your answer should have been 2, 3, 8 and 9. So basically what has happened is we have 2 sorted lists which we actually have to merge. So what do? We actually start the merging process of these 2 sorted sublists. So what do? First I compare 3 and 2, and then I see that 2 is smaller of these 2. So I will actually say 2 is smaller and I keep the 2 in this place. Then I move my index ahead and then I compare 9 and 3. And then I see that since 3 is smaller, I pick 3 and it gets added into this list, and then the index moves ahead. Now I compare 8 and 9 and I see that 8 is smaller of the two, so I will pick 8 and then my index moves ahead. Now what do I see? This part, all the elements are exhausted. So, and this, in this list, I just have 9. So I will actually bring 9 here. So what I have done is, out of these two sorted sublists, I try to merge them and then make one single sorted list. So out of these 4 elements, I have sorted them as below and I get the list as 2, 3, 8 and 9. And then I go and merge this back to the main list. So 2 goes in its place, 3 goes in its place, 8 goes in its place, and 9 goes in its place. So now what we see is that this part in the main list of 8 elements, the first 4 elements have got sorted. Now what we are left with is the right half. So again we will pick this right half and then we will divide this again into 2 parts. So we will pick the 4 elements of right half and then we will divide it into 2 parts of 2 elements each. That is 7 and 1 is picked first. Now these 2 elements are again divided and we go into the left part, that is just 7. Now since we can't go ahead further and this is just a single element, we will go back and place 7 in its place. Then we go into the right half, which is just the element 1, and we don't really have to do anything because this is just a single element. So we will go back. So now we have the left half which has just one element, we have the right half which has just one element, and both of these sublists are sorted. So we need to sort these two together. So what we do is we put an index onto 7, we put an index onto 1, and we pick the smaller of the two, which happens to be 1, and then the index moves ahead, and since there are no other elements ahead of 1, we are done with this particular list. So what we need to do is whatever is left over in this list, we will just add that element, and we have a sorted 2 element sublist, and then we move ahead and there are no elements in the second list as well. So we will just bring them back and put them in the sorted list. Then we go to the right half, that is just 5 and 4. And then once we pick 5 and 4, we have to go again divide this into 2 parts. So we will just pick 5. And since there is just a single element and there is nothing to sort, we will go back with 5 as it is. We will go to the right half, that is 4. And since this is just a single element, I'll again go back with just this element. So again, I have one element sublist which has just one element. I have another sublist which has just one element. And then I need to merge these two sublists. So basically, I will put 2 indices on top of these sublists. I'll pick the smaller of the two, which happens to be 4, and the index moves ahead. And since there are no more elements in the sublist, I am done with this sublist. So there is only one element here. So I pick that element and my index moves forward, and there are no more elements in this sublist as well. So basically I have a list of 2 elements which are already sorted, which is 4 and 5. So I'll move them back to in its original position. So now what do we see again? We have a sublist 1 and 7, which is sorted. We also have a sublist which is 4 and 5, which is sorted. So at this level, I have 2 sublists which are in sorted order, but these 4 elements are themselves not completely sorted. So 1 and 7 is there, 4 and 5 is there. So finally, I need to merge these 2 sublists to get a 4 element sorted sublist. So what I do, I put an index on 1, which is the starting element of this sublist, and on 4, which is the starting element of this sublist. And then I try to merge these 2 sublists. So I pick the smallest of the 2, which is 1, and then I move the index ahead. Then I compare 7 and 4. I see that 4 is smaller, so I will put 4 in this list, and then I move my index ahead. Then I compare 5 and 7. Since 5 is lesser of the 2, I put it in this list, and then I move my index ahead. And then now this particular sublist is done because there are no more elements. So whatever leftover elements are there, I will just put it into this particular sorted order, and then my index moves ahead. Since both the sublists have been exhausted, I have a sorted sublist of 1, 4, 5 and 7. So all I need to do is take them up and then put them in their place. So basically what has happened is I have one sorted sublist at the main level, that is 2, 3, 8 and 9. I have another sorted sublist of 4 elements, that is 1, 4, 5 and 7. So basically I need to merge these two lists to get my final answer. So what do? I again put an index onto the first element of this sorted sublist and first element of this sorted sublist. So basically I am comparing 1 and this element 2. So since 1 is the lesser of the two, I will take 1 out of this and then move my index ahead. I compare 2 with 4, and since 2 is smaller of the two, I will pick 2 and then move my index ahead. Then I compare 3 and 4. Since 3 is smaller of the two, I'll pick 3 and I keep moving my index ahead. Now I compare 8 and 4. Since 4 is smaller of the two, I'll pick 4 and then I move my index ahead. Next I compare 8 and 5, and since 5 is smaller of the two, I again pick 5 and I move my index ahead to the last element of the list. Now since 7 is smaller than 8, I will pick 7 and then I move my index ahead. Since there are no more elements in the right sublist, what I am left with these two elements which are already in sorted order. So I will just put 8 and then move my index ahead, and then I will just pick the element 9 and then put it in the sorted list and then move ahead. So basically I am done with sorting the elements. So if I have to look at a global view of what I did, so basically what I did was I took all the elements, divided it into two parts. I took this part, divided it into two parts. I took the left half, divided it into two elements, and then when I am left with just one element, I merge them to get a two element sorted list. And then I go up, I go to the right half, I again split it into two elements. I merge them so that they are in sorted list with two elements. Then I have two sublists of two elements each. I merge them to get one list of four elements each. And then I go to the right half. Again, I divide these four elements into two elements. These two elements get divided into one element. These get merged back into a two element sorted list. And this half again subsequently gets merged into two element list. And these two element lists I will merge to get a single four element sublist. And these two are again merged into one 8 element list. So basically this is a really a simple way of sorting elements, that is divide the elements and then conquer. That is divide the elements till a point where you reach till a point where we have just one element arrays, merge them to get bigger sorted lists, and finally merge them to get a single list of sorted elements. Next we will try to look at the algorithm for merge sort. So there are two parts to the algorithm for merge sort. One part actually does the recursive merge sort, and the other one merges your sorted sublist to get a final sorted list. So this is the first part of the merge sort algorithm, which actually divides your element, which recursively divides your bigger array into two parts of smaller elements. So let's try to take an example which we have seen previously and try to go through this algorithm and see how merge sort algorithm works for these elements. So when you see the algorithm, it says it picks the input for it is the list of elements. So in this case we have 8 elements, so that happens to be the array A, which is an input for this. So we check if the number of elements is greater than 1. Yes, obviously we have 8 elements, so it is greater than 1. So this line says divide the elements into first two halves and take the first half and copy it into B. So 8, 3, 2 and 9 get copied into B, and this line says copy the next half into array C. So 7, 1, 5 and 4 get copied into C array. Then it says call merge sort on the first half, that is call merge sort on the elements B, that is 8, 3, 2 and 9. So merge sort is recursively calling another merge sort, but this time we are only going to call for the first half. So you can see that I have called merge sort with just the first half of elements. So it's as good as calling yourself. So you again come up and check is n greater than 1? Yes, because I have 4 elements. Then it says copy the first half of this array into B. So what is the first half? 8 and 3. So 8 and 3 get copied into B. and it says copy the second half into C. So that is 2 and 9 get copied into C. Then what am I supposed to do? I'm supposed to call merge sort on the first half of the elements. That is call merge sort on B. So I'm going to call merge sort with just 8 and 3. So when I call merge sort again, I check if n is greater than 1. Yes, n is greater than 1 because I have 2 elements. Then what it says, again copy the first half of this into B. So what is the first half? Just the element 8. So it gets copied into B. Copy the second half into C. Which is the second half? That is just the element 3 into C. And then I again call recursively merge sort on the first half. So that is I'm calling merge sort on the elements B. So I call merge sort on the element A, 8. So here again I come and then I check if n is greater than 1. See, n is equal to 1. So this particular condition fails. So I will never enter here and I go back to my main list. So when I go back, I'm actually coming out of this merge sort B because I went into the left half. Then for the first time in this whole algorithm, I'm going into the right half, that is merge sort of C. So what did I say? We copied the right half, that is 3, into C. So when I call merge sort of C, I'm actually trying to sort this element 3. So merge sort gets called with the element 3. So again merge sort gets called and I check if n is greater than 1. Actually, since it is just one element again, I will not enter into this particular algorithm and then I will go back again to the main merge sort. So I am actually coming out of this merge sort C, where I had passed the element 3. So then the actual step is to merge these two sublists and copy it into A. So this is the merge part of the merge sort algorithm, which takes the B array. In our case, it happens to be just the element 8. It takes the C array, which happens to be the element 3, and then the A array, which is this whole array. So what do? We set I is equal to 0, j is equal to 0, k is equal to 0, some 3 variables. We say while I is less than p, and p, that is till I exceeds the left half and till j exceeds the right half, what do? I check whether b is less than c, b of I. Since 8 is less than 3, since 8 is not less than 3, I will go here and then a of k, I will put c of j. That is, in my main array, I will copy 3, which is what I have done here. So out of these two, 3 is smaller, so I will put 3 into a of k and then k moves ahead. And then since j is less than q fails, because this particular sublist I am done, so I will finish this while loop because I have nothing more to do because this part is done. I am just left with one element. What do? I check is I equal to p. Now I was actually indexing this and I is not equal to p. So what I do is whatever elements are present in B, that is this element, I copy it into A. So 8 is the only element that is left, which I will go and copy back into this particular array. So what has happened is 8 and 3 has got sorted as 3 and 8. So how did we sort? We actually broke this into two sublists. We merged these sublists such that the smallest element goes here and the next smallest element goes here. So we are done with this merge sort. So we have gone back to the parent of this. So when we go back to the parent, we are done with the left half, that is merge sort of B. We are done, and B was this. So for this merge sort, we again call recursively merge sort of C. Now merge sort of C happens to be this. So we call merge sort with these two elements. So merge sort again gets called. We check if n is greater than 1. Yes, n has two elements. So A has two elements. So n is obviously greater than 1. So what do? Again copy first half of this into B. And what is first half? The element 2. Then copy the second half into C. What is second half? Just the element 9. Then we call merge sort on the left half. So we go ahead and call merge sort on the left half, which happens to be the element 2. And since we call merge sort, we will check if n is greater than 1. See, n is not greater than 1. So since n equal to 1, we don't enter here. So we go back to its parent. When we go back to its parent, we are actually coming out of merge sort of left part. We will go and call merge sort on the right part. And right part here again happens to be the element 9. So we'll go ahead and call merge sort on 9. So when we call merge sort recursively on 9, the number of elements we check, is it greater than 1? Since the number of elements is just 1, we will go up and go and meet the parent. So when we go up back to the parent, we are coming out of merge sort of C. So we are done with merge sort of B, which is this, and which is merge sort of C, which happens to be just the element of 9. Next is again the merge algorithm, which takes the sublist B and C and then tries to merge for the element A. So what do? We assign an index B. The array B points to the list sublist left half. The array C points to the sublist right half. And then what do? I is indexing into this array and J is indexing into this array. We check if B of I is less than C of I. B of I, yes. B of I is 2. It is less than C of I, which is 9. So what I do is I go and copy 2 into parent A. So I moves ahead and there are no elements, so I drops off. So this particular while loop, we come out and then we check if I is equal to P. I was actually equal to P because we have reached the end of the list. So we will copy whatever is present in C array back into A array. So we go ahead and copy 9 into its main array, and then C also drops off and we go back to its parent. So when we go back to its parent, we actually have done with the left half of parent, that is 3 and 8. We are right now we are coming out of the merge sort for the right half, which is C. So we sorted it and we got a sorted list as 2 and 9. Now we have to merge these two lists. So I have one list which has 3 and 8, the other list which has 2 and 9, and I will call merge on B, C and A. So when I call merge on B, C and A, B represents 3 and 8 and C represents 2 and 9. So I have to merge these two into A. So again I will get into this while loop. I check B of I in this case happens to be 3. C of J happens to be 2. So I compare 3 and 2. Is 3 less than 2? No. So what do? I go into else and I will copy C of J into A of K. So 2 has to get copied into its parent. So I first put 2 here and then C index moves ahead. Then I compare 9 with 3. So I've gone one step again into the while loop and check, is B of I less than C of I? That is 3 less than 9? Yes. So 3 has to go and sit in its proper position. So 3 is the lesser of the two, so it has gone up, and then B's index moves ahead. That is in this while loop. We will again go and check whether B of I is less than C of J. So B of I happens to be 8. Is it less than C of J? Yes. So I actually go ahead and copy 8 into its proper position. And then since we are done with B of I, so B drops off. So which effectively means I'm done with this list. So whatever is present in this C list gets copied here. So we check if I is equal to P. Yes, I was actually equal to P because we have reached the end of left sublist. So we'll go ahead and copy whatever is present in C of J, that is 9. And then C gets dropped off because that was the only element. So effectively merge sort, first left half was sorted, and then we come out, we are back into the main merge sort, and we are coming out of this particular merge sort. So we have to dive into the merge sort of the right half, and this in this case right half happens to be 7154. So we will call merge sort of right half, which is 7154. So we again go into merge sort. We check if n is greater than 1. Yes. So we will copy first half, that is 7 and 1 into B, and right half into C. So again 7 and 1 gets called as merge sort, and we check if n is greater than 1. Yes. So merge sort on only these two elements. Again divide this, copy 7 into B, copy 1 into C, and just call merge sort on B. So merge sort of 7 gets called. And since n greater than 1 fails, so your merge sort returns back to its parent, and we will come out of merge sort of B, and then we will call merge sort on C, and C happens to be just the element 1. So we will go ahead and call merge sort, and again we check if n is greater than 1, it fails. So we will go back into merge sort, and we are effectively coming out of the right half, that is merge sort of C, and then we have to merge these two elements. So we will go and call merge. We will have two indices, that is B array will be just the element 7 and C array will be 1. So again we will compare if B of I is less than C of J. since 7 is not less than 1, so we will copy 1 into A of k. So 1 gets copied into the parent, and then C moves ahead, and since there are no more elements, he will drop off. Whatever is left gets copied into 7. So B also drops off, and we go back to its parent where we are coming out of the left half of merge sort. Then we will go and call merge sort on the right half of, that is merge sort on C, which has 2 elements. So when we call merge sort, we check whether 2 is greater than 1. Yes. So we divide these 2 elements into 1 element each and call merge sort on the left half, which returns back. Then we call merge sort on the right half, even that returns back. And once we return back to its parent, we have to call a merge on these two. So when we call merge on these two, we will again have B index as 5, B array as 5, and C array as 4. So we again compare 5 and 4 here. So is B of I less than C of J? No. Since C of J is less, this gets copied into its parent A of K. So we are done with this array. So C drops off, and whatever is left, it gets copied in this particular line. That is, copy whatever leftover elements in B into A. So it drops off. So when we go into the parent, we again have to call merge sort because we have a sorted sublist of left and right. So we will compare 1 and 4. Since 1 is less, 1 gets sorted in its parent, and in B moves ahead, and we compare 7 and 4, and since 4 is lesser, the comparison is done here. We copy C of J into A of K. So 4 gets copied into its A of K, and then C's index moves ahead. We again compare B of I, is it less than C of J? Is 7 less than 5? No. So what do? We copy C element into its parent, and then we again check that we have reached the end of the list. So C drops off, and whatever elements are left over, it gets copied here. So the left and right sublists at this particular stage have been sorted into the main array. So this guy can actually be drop off, and we are done with this particular part. So when we reach at this point, we have a sublist 2, 3, 8, and 9. We have another sublist 1, 4, 5, and 7. Now we actually have to go and merge. So again, the merge algorithm will kick in, and it checks 2 and 1. Whichever is smaller, we pick the smallest, that is 1, and C moves ahead. We again compare B of I and C of I. So since B of I is less, we pick B of I, and the index for B moves ahead. We compare the next, again in this while loop, we keep comparing the elements. So 3 and 4, again we compare. 3 is smaller, so B moves ahead. 8 and 4, 4 is smaller, C moves ahead. 8 and 5, 5 is smaller, so we pick 5, and C moves ahead. 8 and 7, 7 is smaller, we pick 7. And since we have reached the end of the list, C will drop off, and we come into this if. So if I is equal to P, I need to copy elements in C, but I is an index into B. So since I is not equal to P, I go ahead and copy leftover elements of B into A. So 8 gets copied, B moves ahead, 9 gets copied, and since B is also done, we actually drop off from B, and we have this sorted list of 1, 2, 3, 4, 5, 7, 8, and 9. So basically we recursively sorted the list to get this bigger sorted list. So we have reached back, and once we reach back, we are actually coming out of this merge. And since we are coming out of this merge in the main merge sort, we are done with sorting all the elements of the list. So this would be our final answer. Now next try to analyze the time complexity of merge sort. Now, as I said initially, the time complexity of merge sort happens to be theta of n log n. Now it's interesting to look why we actually call it as theta of n log n. Now, if we look at the way we sorted or merge sort, at the first layer we have all the elements. We divided it into two sublists at layer 2, and then we again went ahead and divided it into 4 elements at layer 3, and then we finally divided it into 1 element each, and then we merged back and with the sorted elements, and we again merge back with the sorted elements, and then finally we merge back all the elements as sorted back into the layer 1. So what we see here is there are 3 layers of processing. At the first layer, we divide it into 2 elements. At the second layer, this gets divided into 2 elements. At the third layer, these elements get divided. So at each layer, I have 8 elements here. So on the first layer, I have 8 elements. The second layer, I have 8 elements. The third layer, I have 8 elements. And how many such layers are there? 3 layers. So there totally I have 8, 8, 8. So I do processing on 27 elements, 8 into 3. So basically I can say that there are 3 levels and there are 8 elements per level. So we will ignore this 4th level because there is no processing done here. We split and go back. So processing of merging is done at layer 3. So we can safely ignore this layer because there is no processing, so no time complexity is incurred at this 4th layer. So the total operations are 8 into 3. So 8 elements at each level and 3 such levels. Now I know 8 is actually n, but how do I represent this 3? So let's say I take the log of n. So I have 8 elements. So suppose I take log of n, which is log of 8. So how can I write log of 8? I can write it as log of 2 cube. Now we know by property of log that if it is log 8 to the power b to the base a, I can write it as b log a to the base a. So in this case, I can bring 3 down and it happens to be 3 log 2 to the base 2, and log 2 to the base 2 is 1. So this is actually 3. So what I actually did was 3 is nothing but log 8 to the base 2. So I can represent 3 as log 8 to the base 2. So what this effectively means is that the total operations happens to be 8 into 3, and 3 I can represent it as log 8 to the base 2, and log 8 to the, so this I can write it as 8 I can say as n, and log 8 to the base 2 I can say as log n to the base 2. So the time complexity is n log n. So I have n elements, 3 levels of operation. So it is n into log n, that is n into 3 levels. So this is the time complexity of merge sort algorithm and the complete merge sort algorithm as such. Thanks for watching.